Okay. Okay, so before I finish up and then go to SQL, I do want to say that as you know, I want to write a few more constraints here. There's no, it can't have multiple. Okay, a table, unlike primary keys, you can have multiple foreign keys. Okay, you can reference multiple tables. Okay, just so you know. So for example, if I want to have another table, housekeeper, all right, and then I have housekeeper ID, right? And I want to assign one housekeeper to each of the property, right? I could have another foreign ID housekeeper ID here. Okay, so that basically there's to build a relationship like this. All right, that is just a very easy example to show you that foreign keys can have more than one in a table. Now, primary keys never. Okay, now another concept. Remember I mentioned about combo keys? Okay. It shouldn't be surprising to you, but still I have to make sure I mention. If today the host, instead of the host ID, it was using a combo keys as first and last name that we explained earlier, used as an example, then the foreign keys in the property needs to be also that combo key. They need to be exact match. If I'm foreign or referencing another table's primary keys, I'm getting exactly the primary keys, what it look and feel, exactly look like, and the value has to be all the same. Any question? Yes.
So in the case of if it was first and last name.
Yeah,
Would you need two separate columns like host?
Yes. Then in here, forget about this. I'm saying that if there was first and last name, if there was a first and last name, two columns to make the combination keys. Yes, we know that it could repeat itself. Just make an example. It's not the best options for primary key. We established that, right? Primary key is the best option is what? Always a low, like randomized number generated automatically by system. Yes, we established that. But in case there was a primary keys that was a combo keys, okay? For example, host is first and last name, for example, then instead of the HID, host ID here, it's first and last name that's foreign together from host. Okay, yes.
When we get to the SQL part, can you write the
What? Yeah, we're gonna get there. We're gonna create.
right there?
Create, yeah. Okay. All right. So we go over about some today. So far, we go over about basic relational algebra, right? Let's settle in. I would say that look at the deck again, go through the recordings and stuff like that. If you're confused, record just basic usage of that we use. And then we talked about ID. What is the ID meant for database? Then we introduce the key concept. Under keys, there are primarily one subset that is the keys are primary keys. And we introduce the primary keys concept with some synonyms of combination combo keys and also the candidate keys, right? In that sections of primary keys, we also learned about how to actually build back our relationship between the relations, which is the tables, using foreign constraint. So we can permanently connecting two tables. Now, permanently connecting or creating a primary keys, by default, you get features. And those features, you need to adhere to constraints, right? What are the features? Indexing, checking no dupes, okay? And, use the relationship is the feature. But you need to, these features on the flip side, you have to follow their constraints, right? The database do these free checks for you. You also need to make sure that you understand the constraint of it. or you get error out and you just have to fix it. All right, so then we're gonna learn about, I mentioned that during the break, I mentioned to someone that relational database, in my opinion, most important is 40% that follow me for my career is designing database, like different tables, what data should go where, how many tables we need, how many columns we need, what keys, what forings, what not, what indexes and all that, right? So we covered that. That's like really like 40% of relational database concepts. The second concept is about normalizing, right? Once you design it, you have everything. How do you make sure that it's not going to slow down? At least it lasts longer. It doesn't slow down. That's the normalization concept in the end that we're going to learn. Another concept that's obviously very important is the actual SQL. Now, before we talk about SQL, first of all, we know what it stands for is structure, query, right? It stands for structured querying language. Okay. So SQL is a language, nonetheless, and it's only used for relational database. There's multiple databases out there. Therefore, we need to obviously mention about the elephant in the room. The other sets of database we just put in two baskets. One are all SQL database. The other sets of database that is no SQL, right? It's very easy this way because all the SQL database has interpreters that understand SQL. They're really a subset. There's another set of databases that don't understand SQL. They don't have SQL interpreters. Now, however, they are hybrid these days too. That's beside the topic. We don't have to really go through that. But I just say that we will talk about what are the difference between SQL and no SQL. But first of all, let's talk about the history of SQL. Now, SQL is a structured querying language. Why do we call it querying language, not programming language?
They use like to find like the data that we store.
Yeah. That also, yes. Okay. The real, yes.
It comes compilers. So the we told them like
Getting close. That might be closer to the answer that I was looking for. Yes.
It's mainly to manage and create database.
Altogether, it's pretty much, yes. Okay. One is the very observed reason. First reason is because people didn't think, other than C, C++, Java, anything else is programming language before. They don't even believe JavaScript is a programming language. Like if you were in computer science department, if you're a major in computer science department like 15 years ago, if someone tell you HTML, JavaScript is a programming language, they'll think you're crazy. That's number one. That's actually very bizarre, but that's actually true. Because back in the days, there's no standard, and people don't think that lack of reusability doesn't make a programming language. Like everything that as HTML or JavaScript or like PowerShell, all these things, people think they are called scripting language. They're not programming because they're procedural. Similarly, the word querying is back in the days as sort of like a stereotype of SQL language that is a procedural language. It's mainly meant for reading only. And it's mainly search and lookup only. It's not really, they think that the SQL is lack of functionality as the programming language. Therefore, remember we talked about relational database? Okay, also known as SQL database. It's also actually known as procedural DB. It's not used that much anymore though, but this is also its other name. It's procedural because they think that it's all one dimensional. There's no recursive. There's no callback. Now I'm going to prove that is wrong in the maybe lecture 3 or 4 to come later on when we learn about case, we learn about if, while loop, and we learn about triggers, we learn about transactions, all that. Okay? However, one thing stays true is that you cannot use SQL to create a standalone application. It needs to run within SQL database. I don't know if anybody used SQL to create user interface either. Maybe there are. Maybe they use it to like use numbers to make it into like some nice graphic and stuff. But it's not the user interface or front end that we talk about, right? It needs to lives inside the interpreters of the database management system. That is true. It doesn't live like you build a code and later on you build it and you have a package and you run on exe, or you have a React.js and then you run it on Node.js or whatever, or on someone's Apache, right? It doesn't do that. Okay. Now, as far as NoSQL is concerned, that is not, one thing is obviously NoSQL, they don't have interpreters. The querying of NoSQLs are commonly what language? In what format? Normally in NoSQL. Yeah. JSON, right? Sorry. Usually you use your library of like your Python or Java or whatever, or JavaScript, and then use interpreters that can read JSON. And normally it comes in like this kind of format, like key, and then it has a value like blah, blah, and name has a value like something like that. It's very HTML, very web originated. Whereas SQL, the data is represented in what? What way? Don't follow me on this. Tables, tabular way. Okay? All right. So that's number one. So the difference between the two, right? The second difference is okay. Remember, someone answered the question for me. When I move from file storage to relational database, right? The first use case were banking, and then there's some airlines, and there's some like financial, like tax and whatever, governmental, whatever entity. But the first use case was banking. So someone answered to me, what would the bank want? They want speed, right? They want speed, sure. Now, from bank, now we get a new, from the banks that needing the speed and what? Security, privacy, accuracy, right? That was what the bank wants, right? Now comes new use cases these days after the banks and stuff. The NoSQL. And what are the NoSQL use cases that's fitted for? Do we know?
I don't know. It's just like social media and stuff, but
That's right. Yeah. Okay. One use case is social media. What is the difference between social media, you think, with, let's say, your social media content versus not necessarily your content. I'm not talking about your like birthday or, you know, your content, like how many likes you put, whatever. But like the content that shows up on your feed and your financial data.
It doesn't have to be as secure.
Yes, maybe that potentially possible. Yes,
It's shared among multiple people.
it could be shared across distributed distributions.
It does not have to be fully informative, like it needs no structure.
Yeah, it doesn't have to, like your feed. Doesn't matter if your feed was 5 seconds late, like you're getting posts that someone posted 5 minutes ago, Like you maybe have every second there's someone changing something, but it doesn't matter what you're seeing just yet, right? As long as you eventually see it. But do you want to open your bank account and then you see a number that was a day late or 5 minutes ago? Like, or like when you're trading on some E-Trade or whatever, do you want to see your stock when the stock was going so high and you're still low at some bottom point? You don't. There's a difference. That's one difference. And then social media, another difference is that it's posts and created by massive amount of consumers, right? Rather than like more specific, targeted, structured clients, right? The numbers that come from banks are normally like stock exchange and then their customers and stuff like that. And then they have to verify and all that checks and balance and all that stuff. But social media is pretty synchronized, right? Like if you post something and then you post something afterwards, but let's say you sit in US and then you sit in UK, right? And so, sorry, I said, so you sit in US, you sit in UK, you post something first and then you post something later. But because you're sits closer to me, so I see your content on social media, would that be a big difference? No, right? The order is not as important. Whereas if you go to an ATM, right, or like if you have a share holder on your bank account, checking account, and let's say your mother just deposited $1,000, and you want to withdraw, and you can't withdraw that $1,000 because your $1,000 did not get saved yet before you. You don't want that, right? There's this order is very important. The conditions of this order for banks is very important. Therefore, they come with the NoSQL because these characteristics that we're talking about, last accuracy, potentially last accuracy, order doesn't matter. What matters is you see something, right? But doesn't matter if it's most recent, most accurate record. No, for the social media, for example, or the big data. So AST stands for atomicity. You don't have to write this down. It's all on the. Actually, if I can have this, it stands for atomicity. I'm just gonna read it so that you don't have to write it. Atomicity, and C stands for consistency. I stand for isolation, and D stand for durability. Okay, just so easy sake, A is that atomicity means, what is atomicity normally in philosophy?
It's all or nothing.
Yeah. Does that make sense? All or nothing. So think about like, this is referring to the characteristic of transaction for relational database. What is a transaction? Think of it as try-catch block. Very simple, try-catch block, right? When you're programming, you can have multiple commands, you can have multiple calls or methods, right? But when you're doing try-catch block, what are you trying to do? What are you essentially trying to do? When you add a try-catch, is there anyone who never heard of try-catch blocks? Try-catch, you never heard of it? Try-catch blocks in programming languages, like try blocks, you can have multiple calls of the programming language. Like you can call multiple methods in there, and then you have a catch block beneath it. That's it. You know what you're okay. If anything in the try fail, it jumps to the catch, right? And it has to, everything inside the try needs to be successful in order to proceed, right? So think of it as try-catch. It's automatically a character for a relational database. Meaning that if you have a transaction, which is like multiple step of query in the transaction, if one of them fail, it's going to roll back to I did never do anything before. Okay? Imagine an ATM. If your ATM is a very classic example of relational database at its best, you don't want race condition, number one, right? You never want race condition. Like I mentioned, your mom just deposited $1,000 before you and you don't see it, and you have a negative $1,000. You don't want that. Number two is, let's say you insert your card, and then for some reason the network is down. And then while your network is down, you type in before network was down, type in you want to withdraw $1,000. And network is down, no money comes out. Your bank account now is negative $1,000. Does that ever happen? No, because it will make sure everything is done, or else it roll back to before. That's what an ATM is, using relational relational database transaction. So essentially, it's kind of like try-catch blocks. Follows? Okay, that's A. Consistency. What does consistency stand for? Well, consistency just means that it's going to be consistent. So meaning that if a query is executed, it's not going to randomly get reverted. It doesn't just automatically think that, oh, this should get reverted. And then the next day, like, I didn't buy NVIDIA ever, right? It doesn't do that. Isolation. Isolation means that you can have multiple procedure in one database, like from different network, that's it, right? So for example, what is a good example? Okay, I'll come back with an example later. But anyways, you can have multiple people accessing the same database at once. But as long as they are modifying or updating different units, different records, or different table, the calculation should not impact each other. There shouldn't be a dirty read, like race condition. That's what the isolation means. A table being updated, let's say host table being updated, it will impact if there's any relationship to relational table, like to the property table. But if in case that if it's doing something that's unrelated to each other, it shouldn't have any impacts. It's making sure that you're not changing something and then screwed up someone else's unrelated stuff. Durability just means that it has a consistent backup by default. Relational database actually by default, everything is actually backup in like hardware somewhere on the disk. Normally it's not very obvious, but if a day your computer was down or your server is completely back, they should be almost like a black box that ensure that the data you store was somewhere stored. Okay? And it keep on update by itself. It has the memory to do that. So that's what the S stands for. Base for NoSQL, what does it stand for? Anybody knows? I don't expect that's fine. It stands for basically always available. Okay? And it kind of comes back to what I mentioned before. Instagram just care about you are able, when you turn it on, you're not going to see a blue screen of death. It will show you something. And those information, it may be 10 minutes late. It might not have been, you might not have gotten what Kardashian posted like 5 seconds ago, right? But at least it's showing you something. And that is acceptable. Unlike your stock portfolio, right? This is acceptable. So the database is creating essentially is it will get updated eventually. It will still get updated. It's not going to just drop something that they haven't shown you before. It will get updated. But they care about showing the speed. They care about their availability, meaning like the service is up to their clients more than accuracy. So base stands for basically available. Simple as that. Okay? All right. So given that, the first thing that we need to learn about SQL is a select statement. Okay. For SQL, the most common basic one is the select statement, and it's the safest one to start learning first. Because why? It's read only. It's literally just querying, pick, search, find informations from data in the database. Now, select statements, there are two very there's multiple lines in select statement, and these lines do different things. Sometimes we call lines, or sometimes we call it clause. So the first thing that you need to know about is the from clause. From. This is required in order for, definitely required clause or line in the select statement that you must have always. Okay? The second one is select. Okay? It comes on top of from. It always select, come before from. From follows by the tables. In other words, the table names. Okay, where do you want the data from? Where do you want the data from? Now, we can sometimes have multiple tables that you want to get data from. That's okay. If you have multiple table, you use the comma to separate them. Okay, multiple table. From, simple as that. Where you want to get it from. Where are the data that you want to read from? Okay, those are the schema, yes.
Is it from column or it's from or wait, never mind. It's like
The tape,
where I they put something right?
Huh?
Like when you use where, is it like where?
we haven't talked about where yet.
Oh, okay.
I'm talking about from.
Okay.
The from clause stands for where you want to get your data from. Okay? Are we clear on that's the easiest part? And it's always required when you have a select statement. Always need to specify where is it coming from. Select which column you want to see. Which column you want to see from that table, from those tables. Okay, for example, previously we have host full name, right? Right? That is the column. I want to see full name of all the hosts. You know, I want to see the full name from the host table, right? Or multiple columns using a comma to separate it. Okay? So from the select line, okay, I know that it might be a little confusing because it's a select statement, and then there's all different lines that is reusing the same words. Unfortunately, that's going to be the case. Where is going to be always reused, but just know that this is a reserved keyword. This is also a reserved keywords for SQL. Okay? From is after from you select the table. You put the table in there where you want data from. After select, you put the columns. Now, something new here. Instead of column, if I want to say I want just to return every single column of that table, I just do star. That's the keyword reserved, meaning I want to see everything. If a table has 5 columns, it will return 5 columns information. Okay? Now, last but not least, however, optional, but it's very useful, is the where clause. The where clause, in other words, in select statement, are used to filter, to specify if you have any specific result or instance that you're looking for. You're filtering out instance that you don't want to see, basically. And how do we leverage where as a filter? Yes?
We can use statements like equal to less than.
Yes. we will give it conditions. So where clause will follow conditions. And what is the conditions? And conditions is what we use operands, such as equal, larger, smaller, like, not equal, is, not. These type of things, comparing operands. What is the condition? For example, 1 equal to 1, right? If, when you have an if statement, within that, when you have if, you want to follow a condition, right? Similarly, that condition is doing some type of check, right? Returning true or false, correct? Similarly, in here too, your condition is basically using these basic operands to do evaluation on a condition. Okay? Now, before we go to conditions, we have to understand so that we can compare. There's data types. Okay, just like when you code, storing data, you want to specify those data types, right? So for example, star rating, let's say it's 1 to 5. Not actual star, like that will be picture, but let's say 1 to 5. What is the 1 to 5? Numeric. Numeric type in relational database, int, double, int, double. Flow. Is it flow or long? Yeah, I think it's just double for now. That's fine. Most things will get covered by double anyways. So int is only up to only up to 8 digits. I might be wrong. Because I think it's 8-bit or 16 bits, one of them. So you want to make sure that it's very like edge case if it's gonna ever go over, but I think that int is -2 to the 8th or it's negative or positive 2 to the 8th, whatever. Okay, size wise. Anyways, that's not very important. Strings. There's no such a keyword called string in relational database. Okay? Instead, it's varchar followed by a number. And that number is the size you're allocating to this data type, to this string, the maximum length. Var stands for variable, variant, variable, varies. Char stands for character. If you remember that, then you should also remember that this is the maximum size of the string. That doesn't mean that the string or the text needs to be 256. It could be 1, it could be empty, it could be 200. It's acceptable. Now, on the opposite side, there's a char, also followed by numbers. For example, 10. Actually, for example, 5, very common. This char followed by 5 is actually going to check if your size is 5. So regardless what happened, you need to make sure that this data type is populated with 5 characters. All right? String for now. Another one, date, time. Now, date time is also slightly a little bit different naming conventional wise, like within database, but normally it's like day, time, date. Normally, if you want today's date, time, date, it's normally like the date, like something like that. or today's month. Something like that, normally. Okay, you can store it as date, time, data type when you're creating or you're declaring for that column. But normally, if you want to get date time, this is how you do today.date or something like that, or today.year, whatever. However, there's a caveat. Daytime is you can use it for your project when you have a small lab or a small company, you can totally use it. When you will realize when you work for a big company like Google, or if you work for a big company that's multinational, that daytime is not really heavily preferable. They like to use a number, a very long digit number. I think it's 9 to 10 digits number called epoch time. What is it? Can someone tell me? Someone, yes.
Is it like it's like common time for everybody, but it also starts not with our time, but like before it? Maybe?
It starts at a specific time, yes. What is the specific time?
I forgot the actual year, but the time that we all started counting with the computer, pretty much.
Yeah, yes, I always keep forgetting, but yes, you
It
know,
was January 1st, 1970 at New Year's,
yeah, January 1st,
1970.
like this, right?
Yeah.
So basically, epoch time starts here. So this is 0. Everything else, the next seconds is 1, basically, all the way to today. So each seconds from that time on, there's a specific number for it. Now it's like a 2, is it 8 digits or 16 digits? Anyway, I think it's 8 to like 16 digits, I don't know, whatever, I think. It's just a long number. But it's specific, is this GMT time? I think,
Yeah.
yeah, right? London time, GMT, I think so.
It
Yeah.
It also handles leap year.
Huh?
It also handles